The last part of our exercise is about algorithms. So we will cover now two algorithms to search for some elements in your data structure and one algorithm to sort your data structure. So we will start with linear search. Linear search is the simple algorithm that is also often called sequential search. So this linear search is used when you want to find one specific element in your data structure. So let us open our Eclipse and let us create a class with the name linear search example. So first, now we will create a method that will pursue this linear search, and afterwards in our main method we will initialize some specific array with some elements, and we will apply this linear search method that we have created before in order to find some specific method. So first we are creating now this method. This method will be public static, and it will return value of integer data type, and we will name this method linear search. This linear search method will take two parameters. The first parameter will be the array where we would like to search for our element, and the second parameter will be the element itself that we would like to find. So first it will be some array. It will be of integer data type and some specific number. Let us name this number num, and the array with the name array. And in order to search for the element, we will use the for loop. For, and inside we will first initialize I with 0, and the search will take place as long as there are elements in our array, so that the loop will go through each element till the end of array. In order to use now the last element of array, we will use the length. Array dot length and increment at the end. If our element that we would like to find is there, that is, if array with some index e equals to the number, to the value that we want to find, then we would like to return the index of this value. And this search will take place as long as there are any elements in the array. And if not, if our element that we would like to find is not in array, then we would like to return -1. So that's all. This is how the method, linear search method, looks like. Now let us apply this method. For this we will create our main class, main method, public static void main string arguments. Okay, so now let us create some array with the name my array, and we will populate this array with some numbers. Doesn't matter, just some random numbers. And we would like to find some specific number. That is, let us say 45. We want to see whether this number in our array. So next we will, now we want to apply our linear search method in order to find this element. So in order to do this, we will now write linear search, the name of our method, and we are opening braces, and at the first, the same as here, first position we need to put the name of our array, and second position we need to put the name of the element that we want to search for. So first we are putting my array, and next we are putting num. So that is, here we are applying our array, our method. However, we want that the results of this operation are printed to the console. That's why we will just put this inside of the system out print line statement, and we will just put some sentence here just to make it look nice. So num is found at index, and we adding this method. So what we want to see in the console, we want to see first the value of this variable, that is 45, is found at index, and then we want to receive the index of this value. So indeed 45 is found at index 1. If we will change this, for example, for 32, we will receive index 3. If we will write here some element that is not in our array, then we will receive -1. So this is exactly what we wanted to have. So this is linear search example. The next search is binary search. So next, let us create a class that has a name, binary search example 2. So binary search is a technique that works only with efficiently with sorted lists. So linear search is a pretty slow method. Binary search works quickly, especially when you have very long arrays, very big arrays. So then binary search might be better. However, your array should be sorted. So the same as in linear search example, first we will now create the method binary search itself, and then we will apply this method in our main method. So this method will be of public, static, and void type. That is, it will not return any values. The name of this method will be binary search, and this method will take several parameters. The first parameter will be the array. The next parameter will be the lower then parameter upper and parameter number that we would like to find. So as you have already seen in the lecture video, the binary search uses the midpoint when it searches for elements, and our lower and upper bounds, they will be used to calculate those midpoints. So, and this will be our method. So first we would like to calculate this midpoint, that is lower plus upper over 2. And while lower less equals than upper, and we want to check if array, the midpoint of the array is smaller than our number that we want to find, then lower equals to midpoint plus 1. Otherwise, else if array's midpoint, if it equals to number, then we would like to print a statement to the console that our element was found. So system out print line element is found at index, and we are putting this midpoint index. And we are breaking our while loop. Otherwise, upper equals to our midpoint minus 1. And our midpoint will become less. So lower plus upper over 2. And we're checking if lower is bigger than upper, then that is that the element was not found there in our array, then we would like to print this to the console too. System out print line element is not found. Okay, so here in this part you see how we have written down our binary search method. So in order to understand this binary search method from the conceptual, from the theoretical perspective, first, like in order to understand how it is constructed now, first you have to understand why it is constructed in this way. And for this purpose, please refer to the lecture video where Stefan Lessmann explains you why and how binary search method is constructed. And then please come back to this code, and then you will understand it better. So now we want to use this binary search in our main method. Let us write our main method, public static void main string arguments, and first we are creating one array that is called my array. And we are populating it at the same time, so this array will have the following sorted numbers: 15, 25, 35, 45 and 55. So we would like to find the number 45 that is now saved in the variable num. And we are initializing also our upper, that is my array, so the upper bound of our array, and that is length minus length of the array minus 1. So this is the index. And now we are applying our binary method. Binary search, so this is the name of the method here, exactly. And now we have to put inside here 4 values. So the first, let me enlarge it. So the first is the array, so we are just putting the name of the array itself. Then the lower is the index of the first element, and this is 0. Then the index of the last element, and this is length minus 1. So this is actually upper. We have written it here, so I will just put this variable here. Alternatively, you can just put this expression here instead of writing this whole row. And the last is the number that we would like to find. Okay, so at the result, we see the element is found at index 3. And indeed, it is the result that we were expected to see. So this is the binary search. The main condition of using this binary search is that your array is sorted. So what to do if your array is not sorted? You have to sort it. And the next algorithm is can be used to sort your array. So let us create a new class that is called BubbleSort. And this BubbleSort algorithm, it is also known as the simplest algorithm that is used for sorting. So the main idea of this sorting is that the next element is compared with the current element. And if the current element is greater than the next element, then the elements are swapped. So let us now create the main method, and we will write everything already inside of the main method. So public static void main string some arguments. And first that we will do now, we will now initialize an array with unsorted list of numbers. Some array that is called numbers with some elements, just something random. So it's enough. First, what we would like to do, we want to display the original array just for our information. And after the applying of the sorting, we will display the result of our operation. So we will display the elements of our array once more. So in order to display array, so we want to print all numbers of the array to the console. You remember that for this purpose we need to use the for loop, and that is what we will do. Display original array system out print line, and we want to print original array. And now the for loop comes in place. So for e equals to 0, starting from the first element with index 0, as long as our I less than the length of our array numbers length, we will proceed with our loop, and with every run of the loop we will increment it with 1. And we would like to print now the index, the value of the array with this index, so this index e, and some space. Okay, so let us, where do we have an arrow? Okay, it's not num, it is numbers, the name of our array, of course. Okay, so we see now that is our original array here. If I will use here not print line but just print, then we will have everything in one line. Okay, so you see that our array is here unsorted. So now let us sort our array. And now we will apply BubbleSort. Okay, so first we will initialize one integer n that will correspond to the length of our array. So this is numbers length. We just don't want to write every time numbers lengths when we need to use this method, this length. So we will just write n every time. And we need one temporal variable that is now, for the beginning, it is assigned to 0. So now we're using the for loop with initializing I with 0, and as long as I is less than the length of the numbers array, that is now equals to n, we will proceed with our loop, and with every run of the loop we will increment our I. And inside of our first loop we will have another second loop, our nested loop for integer j equals to 1, as long as j is less than n minus 1. We are executing our loop, and the j is incremented with every run. And inside of our nested loop, we are writing a condition if the numbers array and the value that is on j-1 index is greater than numbers of then the element of the array that is on j index, we are swapping elements. Swap elements. And now we are using our temporal variable, since we need to save some results that we have in between numbers j-1 numbers just a second. Yeah, with the index j-1 equals to numbers array with j, and numbers j is now assigned to our temporal variable. So here this nested for loop is used here for swapping elements. Exactly these three rows are used to swap the elements, and those rows are used to find the corresponding elements, like to check whether two elements that are on two specific the values of two elements that are on two specific indices, if the first one has bigger value than the second one, then this takes place. So then those two elements will be swapped. So afterwards, as the result of our bubble sort, our elements of our numbers array will be sorted. So what we want to do, we want to see how our sorted array looks like. So that's why we will now print it again, display sorted array. So sorted array after bubble sort. And now, so this everything here stays the same, and we want to start with the new line, so we'll just put here literal n. Let us execute this code, and you see, because I have to, just a second. Yeah, so in order to use literal, it should be with backslash, not with slash. Exactly. So you see here the original array and the sorted array. So summarizing our algorithms, in order to pursue a search within an array, you can use linear search or binary search. You need to understand what are the differences between linear search and binary search, and when to use each of them. Binary search you can use only with sorted arrays, and if your array is unsorted, then you have to sort this array, and bubble sort is one of the methods that you can use to sort your array. So that's all. You don't have any homeworks for this last exercise. However, you have a lot of codes on your slides. from your lectures, so please feel free to try them in Eclipse and play around with them. So I thank you for your attention, and I hope that you are enjoying Java, and I wish you good luck in your exam. Bye.